Okay, welcome back. Okay, as a startup here, I would like to revisit the solution of homework 1 using the zinc automation toolbox. Previously, I was using 10 ohms as the co-resistance, which actually affected the amount of current drawn using the RLC circuit while operating. So I have used typical values of the co-resistance of about 1 kilo ohm, and I have also adjusted the resistance of the coil available at the lamp side, and I have used 2 kilo ohms. So now once we hit the run push button, we will consider the considerable amount of reduction in the current flow, the current value drawn by this RLC circuit. As you can see here, once we hit the start push button, now we are speaking about 24 milliamps, which is really good. And once we hit the H1, now we have about 60 milliamps. So this is actually what we will face in actual implementation of RLC circuits. So now coming back to the main topic of this presentation, here we have the professional schematic diagram of the RLC circuit shown previously. I have generated those schematics using the Design Spark Electrical, and you are asked to read them properly and to understand them fully, and to be able as well to reproduce them from scratch. So this is the first solution according to the solution provided for you in the handouts, where we are assuming we have plenty of normally open, normally closed contacts available at our disposal, and we have everything fine. And now we are assuming that the K2, K3 will actually be sufficient to operate the power contactors, since we are assuming we are dealing with 24 volts operated power contactors. Now, once I tried to assemble the RC circuit shown in part 1, I was faced with the problem of insufficient resources. So I have to reconsider the whole circuit and redesign it from scratch in order to accommodate the available resources, where I have actually 2 power contactors that are operating using 220 volt AC instead of 24 volt DC, and I have to reconsider that. In fact, the main issue I was facing earlier, that I have 2 power contactors that are operated using 24 volt DC, but I was lacking the overloads. So I have to reconsider this. And another issue where I was faced with the lacking of sufficient number of normally open, normally closed contacts, where I have in fact relays with 2 switchover contacts. So I was unable to realize the circuitry shown here. So I came up with another alternative, where I have introduced K1, K2, K3 as being relays, and K4, K5 as being the power contactors, and I have used here the available normally open, normally closed contacts available at the power contactors in order to realize the electrical interlock. And eventually I have the same functionality. However, the control logic here comprises 2 distinct voltage levels, namely 24 volt DC and 220 volt AC. Okay, compare this to the first solution, or the original solution, where we are solely dependent on 24 volt DC in order to operate the whole RLC logic. So keep this in mind. And now, as you can see here, we have this prefix before the S2 tag, and this actually tells us that this component is available at location L1. L1 stands for the operator interface, and the remaining of the components are actually available at the L2 location, that is the power cabinet. Okay, so whenever we are actually designing a complete circuit, we need to come up with a professional schematic book, let's say, and we at the end of the design cycle, we need to assign it as built and QC passed, in order just to complete the design cycle, where we are telling the company that the circuit was actually wired and implemented as desired, as designed, and this can be told by seeing the stamp as built, and the other stamp tells us that the RLC circuit has already passed the QC test. And once we read through this wiring book, we can see it consists of 11 pages, and those are the functions. F1 tells us that this is the first function, namely the control circuit, and F2 is the power circuit, and L1 tells us this is the operator interface, and L2 tells us this is the location of the power cabinet, and those are the description of the available pages. So now reading the first schematic diagram, this is actually referred to as line wiring diagram, and it shows us how the various components are interacting over the schematics. Here we have the first function denoting the control circuit, and this is the second function denoting the power circuit, and this is the first location denoting the operator interface, and this is the second location denoting the power cabinet. And as you can see here, we have the operator interface, where we have the set of push buttons and the pilot lamps and the selector switch that is not used. And as you might remember, as I told you in the first part of this video, here I was liking the use of the X8 terminal, which actually connects the operator interface to the power cabinet through the wire W1, and those are the two motors. This is the third location available at motor 1, and this is the fourth location available at motor 2, and they are connected to the power cabinet through the wires W2, W3, which are connected to X6 and X7 terminals respectively. Okay, so those are the various components available in the following schematic diagrams. Okay, so let's start by investigating the first actual wiring diagram. Here we have the power cabinet. Okay, here we have the power cabinet. As you can see here we have here we have the wiring diagram of the power supply, and this is the E1. This is the three-phase AC outlet or plug connected to the outlet. And actually, I was operating the shown circuit using only one phase, since I was operating from a residential housing. As you can see here we have the circuit breaker, and which actually responsible for providing the AC voltage to the DC power supply that actually generates 24 volts through the fuse 1. Now this is very interesting. Here we have Q3 and F1, and we can follow the lines. Those are the source and destination arrows, and those are the potential marks for the wires. Okay, so if we come back like this and we just followed those tags, as you can see here, we can just press them and we can continue reading the schematic diagrams. Okay, so now here we are at the control panel. Here we are at the at the power cabinet, and here we are discussing the control circuit. As you can see here we have the normally closed contacts of the first and second overloads, and those are actually the push buttons available at the operator interface. So this is the functional diagram. This is what we would like to see, or we usually used to see. And now this is the professional way to reflect the various locations into the schematic diagram through the connection of terminals. As you can see here, this place actually is reserved for the S2, and the other one is for S1, and those for S3 and S4 respectively, as you can see here. And here we have the pilot lamps H1, H2, and H3. They are actually appearing right here. Okay, so now we need to follow those arrows in order just to fully read the through the wiring diagram actually. So let's press this one. As you can see here, now we are following this line until we reach the H1 LAN available at the operator interface. So let's come back to this control logic. As you can see here, now we are operating this control logic using two voltage levels, 24 volt DC and 220 volt AC. So now instead of depending solely on K1, K2, K3 in order to realize the control logic, here we are using K1, K2, K3 and K4, K5 to provide the power connection to the motors. As you can see, since I was unable to provide relays with sufficient numbers of normally open, normally closed contacts, and the ones I only have at that time of assembling the circuit is a relay with two switchover contacts, so I was unable to realize the wiring shown here, and as a result I have just switched to this design shown here. Okay, so reading through the next slide, here we have the power circuit. Here we have the third location and fourth locations, and here we have motor 1, motor 2. Here we have the terminals X6 and X7, and here we have the contacts, power contacts of K4 and K5, and those are the overloads. Okay, so this is actually the operator interface where we have the connection between X8 and X9. Notice here X9 is available at the power cabinet and it serves the power circuit. And here we have the operator interface. Those are the wires inside of the cable W1. And here we have various terminals connection points. Here we have 1, 2, 9, and those are actually available at the operator interface. Okay, so what really makes those schematics very interesting and very useful at the same time is the availability of the numbers. You see here now, here we have the wire number, and here we have the component terminals. So whenever we are assigning a manufacturer for this component, say the S1, we tell it, I mean the software, that we would like to connect the components which have which has actually two terminals, namely 13 and 14, and we can do the same for the other components. As you can see here, for the pilot lamps, here we have terminals, two terminals denoted as X1 and X2, and so on and so forth. So reading back to the power terminals, here I have assigned the power contactor, manufacturer footprint, and the information available, and actually the software will automatically generate the terminal tags and marks so that I can speed up the wiring process and reduce the mistakes that might arise. Okay, so this is actually the final shape. If you remember now, you can compare it to the shown power cabinet shown at the part 1 of this video, and you can see here we are having the tags Q3, and those are the terminals. This is the power supply, and those are the power terminals, and those are the power contactors along with their overloads, and those are the relays K1 through K3, and this is the fuse, and those are the terminals. You notice that it actually was different from what is shown here, even though I have stamped it as built. Okay, but just this is to bring the idea closer to your mind. Now, what is really interesting about this generated PDF or schematic diagram is I can trace back the available components. Say I'm interested in seeing where is G1 is actually appearing in the schematic diagram. It will tell me right away. So if I'm pressing G1, it will bring me back to its physical location in the power cabinet, and I can do so with various components, as you can see here. Okay. So imagine that I'm interested in seeing where actually I was using K4. I just hit it K4 and it will tell me now I'm using K4 in those various locations. So since we are brought back here, I would like you to notice that here we have this contact map where it tells us exactly where the contacts associated with the relay or contactor coil were used. As you can see here, K4 contacts, power contacts were used in page 6 and column 4 and row 3. Okay, and the normally open contact associated with K4 was actually used in page 5, which is the current page, I think. Yes, I think it's the current page. Yes, and column 3 and 5. So let's just hit K4 and see this. As you can see here, we have K4 and it is appearing right down the fourth column, okay, and it should appear at the third column as well, okay. As you can see, this is K4 appearing under column 5, okay, and row 3, okay. So we need to switch the number of rows and columns, okay. So, and you can do the same with each and every contact, where you can just speed up the reading process, where you can tell if you don't have this PDF available maybe at your laptop, you can just read through this contact map in order to tell the exact location of the contact of each and every coil. Okay, so now those are the components, and you can see here they are breakdown according to the manufacturer, and here we have actually the reference and the manufacturer and the marks for each component, and those are useful whenever you are generating the bill of materials and whenever you are going and willing to come up with an estimate of the cost, so that you can allocate the needed amount of money and so on and so forth. I hope this clarifies some of the aspects of the wiring for you. Now, finally, the design process is not restricted to certain practices, and it actually depends on the experience of the designer. So since I have introduced here two power levels, as you can see here in the control circuit, I have used plus 24 volt DC and 220 volt AC. I came up with this idea where I need to implement the same functionality, however, using different components. Here I'm depending mainly on the 220 volt AC voltage level in order to realize the same functionality, and you are asked to reconsider this solution and to come up with the needed schematic diagrams using the Design Spark electrical software. So you can see here I'm using the selector switch S7, and it's actually since it is retentive, it actually holds its place, and whenever it's closed, it will keep closed until we open it. And here we have used a selector switch with 3 position, and it is key operated. Okay, and as you can. Okay, as you can see here we have a selector switch with 3 positions. Here we are wiring this wire to the 4th lamp and 5th lamp and 6th lamps. Here we have, and this branch will actually activate the contactor K4 along with its indication lamp, and there is a middle position where we need to stop. So no motor is actually running or activated, and the other branch to the right will actually energize the coil contactor K5, and the lamp H5 will only energize whenever the contactor is actually closed. So this is actually to bring your attention to the level of feedback. Here we don't care about the actual status of K4, so we solely depend on the status of or the position of the selector switch once it is in the far left. Okay, so the lamp will be eliminated regardless of the status of K4, while to the branch to the right, the H5 will only be eliminated whenever K5 is actually energized. So one other issue, hopefully you have noticed in the video in part 1, I have actually, once I tested the fault condition, I started the second motor. However, when I tested the overload condition, I have just pulled the trip or the trigger of the first contactor, even though it was not running. And this is because of the OR function shown here in the RLC diagram. So I wish you all the best and keep doing well. Thank you.